Number 1. Rewrite each of the following exponential expressions involving rational exponents. Remember, rational exponents means they're fractions, as radical expressions. Evaluate the expressions without a calculator. So 64 to the 2/3. The big idea is that it's power over root. So this is really the third root of 64. Now I can either put the square on the inside or square the whole thing. Because I'm going to evaluate these without a calculator, I'm going to want to make them smaller first by taking that cube root, and then I'll square it at the end. Well, what's the cube root of 64? Well, that's 4 squared. 4 squared is 16. So 64 to the 2/3 is 16. 125 to the 2/3. Well, it's power over root. So it's the cube root of 125, and I'm going to square that. The cube root of 125 is 5 squared gives me 25. So the big idea that we need to know is it's power over root. 16 to the negative 3/4. Well, first let's deal with that negative exponent. That negative exponent means take the reciprocal and make the exponent positive. So I have 1 over 16 to the 3/4. 1 over power over root. The fourth root of 16, I'm going to make that smaller first, and then I'll cube it. I could put that cube inside, 16 cubed, and then take the fourth root of that, but this is the best way to do these without a calculator. 1 over the fourth root of 16, well, 2 times 2 times 2 times 2 gives me 16, so that's 2 cubed, which is 1 over 8. 2 cubed is 8. So 16 to the negative 3/4 is 1 over 8. It's so important that you understand fractional exponents are power over root. Explain why we define 5 to the 1/3 as the cube root of 5. Just don't say it's power over root. Why did we define it that way? Well, we said 5 to the 1/3. If I cube that, this, using power of a power, 1/3 times 3 is 1. That gives me 5 to the 1. So 5/3 cubed has to give me 5, somehow. And I really should be using sentences here because we see the word explain. So maybe we know that 5 to the 1/3 cubed equals 5 to the 1 because for a power to a power with exponents we multiply. Therefore, 5 to the 1/3 cubed gives me 5. What to the third power gives me 5? Well, that has to be the cube root of 5. The cube root of 5 to the third power gives me 5, because those undo each other. So therefore, we define the cube root of 5 as 5 to the 1/3, or 5 to the 1/3 is the cube root of 5. But it's because we need this power to a power property to hold that we define 5 to the 1/3 as the cube root of 5. You need to know how to use fractional exponents, but also you need to know why we define them that way. It's important you understand why we defined 5 to the 1/3 this way. The expression w to the negative 5th over w to the negative 9th to the 1/2 power is equivalent to w to the a. Determine the value of a. Well, when I see this division in here, when I divide quantities with exponents, we subtract. So w to the negative 5th, what's negative 5 minus negative 9? Becomes a plus, so it becomes 4. So this is w to the 4th to the 1/2. There's two ways you can look at this. You can take the square root of that, or you can apply a power to a power property and get w squared. So a equals 2, because that's what I'm looking for. W to the a, w to the 2. So we had to use power to a power, or you could have said, I need the square root of w to the 4th, which still gives you w squared. Let x be a positive number. Maria claims that 4x to the 1/2 equals 2 square roots of x. Explain Maria's mistake and correct it. So, what did Maria do wrong here? Well, the square root of x is definitely okay. It's the 2 that's not okay. Maria found 4x to the 1/2. She found the square root of 4 and the square root of x, which is 2 radical x. That's what she found. But in our case, only the x is raised to the 1/2. So 4x to the 1/2 is actually 4 times the square root of x, because the square root of x, power over root, the 1/2 power, is the square root. So we have to be careful and make sure we know only the x is raised to the 1/2 here. The whole quantity is not raised to the 1/2. Be careful. Number 5, rewrite the following expressions in exponential form. Which two are equivalent? So it's very important you know what is a square root. A square root is the 1/2 power. The cube root of 5 squared, well, it's power over root. So 5 squared over 3. Power over root. Well, this is really a square root, so there's really a 2 hidden there. So this is 5 power over root 3/2. Power over root, this is 5 to the 2/3. So which two are equivalent? The cube root of 5 squared is equivalent to the cube root of 5 quantity squared. It's important to understand that we can either do the power first and then take the root, or we could take the root first and then raise it to that power. It doesn't change the value, it just changes the order that we do it in. Is it true that 4 to the 1/2 cubed equals 4 cubed to the 1/2? Explain how you know. So let's start with 4 to the 1/2 cubed. Well, 4 to the 1/2, that's 2, because that's the square root of 4 is 2, cubed gives me 8. So this side is 8. 4 cubed, 4 times 4 is 16, times 4 is 64 to the 1/2. Well, what's the 1/2 power means take the square root. The square root of 64 is 8. So it does appear that they are equal, and we can go through it showing this way, or we can be nifty and say, I have a power to a power. 1/2 times 3 is 4 to the 3/2. I have a power to a power, so that's 3 times 1/2, that's 3/2. So we have some flexibility when we work with rational exponents. We can either take the root first, we can take the square root first, or we can raise it to the power first. That's it for rational exponents. We'll look at some more of them tomorrow.